Good morning, Algebra 2. We have the second part of your twin in front of us, and it's calculator part. So let's go ahead and do it. This is compute the product. We're going to go to second matrix. I'm going to scroll on over to edit. I'm going to put this little guy right here in matrix A, and it is a 2 by 3. Hopefully your test Friday goes well. That'll be entirely up to you though now, won't it? All right, you got to quit out after you put some stuff in. Back to second matrix, scroll on over to edit. And I'm going to put B, or the second matrix in B, and it's a 3 by 3. You need to be playing along. If you're in class and you're just watching the video and you're not trying to do this problem, you're not going to know how to do this problem. And you're going to miss super easy stuff. You might be sitting there, yeah, whatever, Milbrath. Well, good luck. Don't listen to the adult who has advice to give you. Although us just have to learn our lessons the hard way. All right, so now we're just going to do this. This was basically A times B. The second matrix A, press enter. Second matrix, choose B, press enter, enter. And there's our result, assuming I didn't make a typo. I'm in a little bit of a hurry, but the gist of there is how you do the problem. And if I made a typo, please let me know I made a mistake. You're not going to aggravate me. I'm well aware that I am not flawless. Perfect. All right, what are we supposed to do here? We're supposed to do C times A minus B. Now, if you do this as it's written right here, you're probably going to have an issue. You really are. But let's put these things in. So I've got a lot of replacement to do. A is a 3 by 2. 3 rows, 2 columns. B is also a 3 by 2, if I can talk this morning. And then we have C, which is probably a 2 by 3. All right, so there was a perfectly good waste of 5 minutes of my life there. Now let's try typing in what they wrote, and it's probably not going to work. Second matrix, let's see, it was C, parentheses, second matrix A minus second matrix B, close parentheses. Invalid dimensions. That doesn't mean that we can't do this problem. It doesn't mean that. One of the things you can do, and I'll show an easier way of doing this, but you might learn how to play with your calculator, is you can just figure out what A minus B is. Now, order is very important in matrices. And I'm going to store that. There's a little store key right here next to the 1 and the 4 into matrix D. All right, well, now I can do C times D. And there is an answer. Now, the storage feature is going to be something some of y'all just won't ever grasp. And some of you will. And like I said, a lot of kids probably are not playing along. I can't fix that. I can't fix apathy. I wish I could fix apathy, but I can't. I've done this for a long time. What might be easier for you to do is to just think about the distributive property and realize that this is CA minus CB. Let's see if your calculator can do that. I bet it can. So we go to second matrix, we choose C, we do second matrix, we choose A, minus second matrix, we choose C, second matrix, we choose B. See, same thing. Pick your poison, kids. All right, this one, word problem. The goal here is to figure out how many female students are in the College of Business and how many male students are in the College of Arts and Sciences. Let me scan my dimensions here. We have a 3 by 4. And here we have a 4 by 2. If I was to take this matrix that I'll call A and multiply it by B, I could do that because I'd be doing 3 by 4 times 4 by 2. Now the resulting matrix would be a 3 by 2. And what would happen is the top two columns would be borrowed from here. This would be female and male. And these 3 rows would be these guys, arts and sciences, business, and engineering. So that's what I'm going to do. I'm just going to multiply these two things together. And order is very important, first, second, and then I'm going to go push some buttons. You do need to know that 60% is 0.6 as a decimal. You kind of do. Because you're not going to put these in as whole numbers. We don't do math with percentages. We convert them to decimals. All right, matrix A is loaded. Time to put in B. She's a 4 by 2. Kind of a small college, isn't it? All right, now I'm going to do the multiplication. It was A times B, I think. Second matrix A, second matrix B. And there's my results. Hopefully I didn't make a typo. If I did, again, it happens. That's why you shouldn't blindly copy me. I would love to spend a bunch of time on this morning. I just don't have it. So the goal is to figure out how many male students are in the College of Arts and Sciences. Arts and Sciences would be this one right here, and it's males. So 1,391 males. Oh, I'm sorry. That's the second part, 1,391. The first part was females in College of Business, which looks like that guy right there, 631. There you go. It's not a hard problem. What do we have here? 4. Each matrix is non-singular. Find the inverse of the matrix. Be sure to check your answer. You get to do this with a calculator, so it shouldn't be a problem. So the only way you can find the inverse of a matrix is if it's a square matrix. This one happens to be a 3 by 3, so it's a square. Hopefully you understand that. And this is super duper easy with a calculator. So I just typed in the matrix into A. Now I'm going to choose matrix A. And I'm going to hit the inverse key, which is there at the matrix button. Bam! I have an answer just like that. Easy peasy, lemon squeezy. Again, play along so you know where that button is. Ask your neighbor if you don't know where that button is. Ask somebody where that button is. All right, solve using the inverse matrix method. I don't care if you do this with double REF or not. The inverse matrix method, basically what we do is we have two matrices. We have what we call a coefficients matrix. -5, 3, 2, -4. This is a coefficient matrix. And then we have a solutions matrix. Which is these things right here. Or actually, I don't know, let's call that a constant matrix. Not a solutions matrix. Now let's think about how this works. The idea is if you take the inverse of this matrix and multiply it by this constant matrix, you will get your answers, X and Y. That's how it works. So let's do it. More button pushing. So I've got a coefficient matrix, which is just the coefficients of the variables. That's all it is. Now I'm going to do this with double REF too. You know, I remember being taught this in high school, and it has limitations. The limitations are like it's useless to you if there's no real answers, or if it's an independent system. Sorry, a dependent system. It's useless. But whatever. I'm not in charge of what's taught to children. I just teach it. They say, Milbrath, teach this, this, and this. Okay, what I'll do. Let's see here. We're supposed to take the inverse of matrix A, multiply it by the constants matrix, and I should get some answers, 2 and 6. And these guys were again 2 and 6. So X is 2 and Y is 6. Now, compare and contrast that with reduced row echelon form. And I'm not going to write a bunch of stuff down here. I don't care if you do RREF. I would. But if we do double REF, we're going to scroll our little butts on over to edit. She is a 2 by 3. And we're just going to put in the augmented matrix. I'm a really big fan of what's called Gaussian elimination. Jordan-Gaussian elimination, I think that's what it's called. But we do it with reduced row echelon form, or at least the row operations that get us in reduced row echelon form. So you guys are probably more comfortable with that. Do it on the test, that's fine. We're looking for double REF, 2 below the cumulative summation function. And that was stored in matrix A. And there you go. You got the same thing. X equals 2. 1Y is 6. It's quicker too. Use the coding matrix to encode the message come here. Now, what we're going to do is we're going to take this matrix A, and it's going to be first. It's always first. So we're going to multiply it by b, which is going to be the encoding of this. So if we were doing this on paper, it'd look like this. And we're going to have to encode come here. So the letter C is a 3. We're going to work our way down. The letter O is a 15. The letter M is a 13. The letter E is a 5. We have to have the same number of rows here. Then we have the space, which is a 27. Then we have an H, which is an 8. An E, which is a 5. An R, which is an 18. And an E, which is a 5. But the coding matrix comes first. Remember that. That's how it works. And then I go back into matrices and I push a whole bunch of stinking buttons. I'm kind of tired of pushing buttons. All right, quit out. Work on matrix B. Also a 3 by 3. Some point in time today, I've still got to do a second twin. I don't know why I do this to myself, but I'm going to give you an extra credit twin. Some of y'all need the points. Some of you honors kids need the points. I have an honors kid in particular that I'm betting won't do it. Maybe I'll get proved wrong. Anyways, there's the layout. Matrix A, matrix B, and there's my encoding. That is the encoded result. Just a rudimentary thing we can do with matrices. One of them is we can encrypt communications. Now, if I'm right, if I take my encoding matrix, which was A, find its inverse, and then multiply it by that, which I can't do that yet, can I? Let's store that to matrix D, or C. I'm not using C right now. Take the inverse of A, multiply it by C. I should get the original encoding back. 355, 15, 27, 18. So that's the encoding. All right, another one of these. Use the coding matrix and its inverse to decode a cryptogram. So we're just going to take this guy right here. He's going to come first. And we're going to multiply it by the second one. And it's going to be second by that one. See, they're saving you time here. They gave you the inverse, all that good stuff. Now you're going to have to decode. What is this thing saying? You are going to have to decode it. So again, more pushing buttons. Kind of boring, isn't it? But it's easy. So there's that. All right, so we're finding the inverse of the second. Well, we don't actually, we have the inverse of the second one. Almost did too much work. And there is my decoding, 7421, blah, blah, blah. So let me copy that and let's see what it says. It's got a 0 in there. That's kind of interesting. There is no 0th letter. Hmm. So what's up with the 0 there? Well, it's nothing. It's apparently the equivalent of a 27. It's nothing. See how there's nothing? Just call it space. Anyways, 7 is a G. We work our way down. 15 is an O. There's 2 of them. 4 is a D. Got a space here or nothing. 12 is L. 21 is U. 3 is C. And 11 better be K. Good luck. Because you're going to need some luck. Moving forward. Solve the system using matrices, row operations. If system has no solution, say it is inconsistent. And we're going to do this using double REF. We're not going to recreate the wheel here on this. So we're going to go to second matrix. We're going to scroll over to edit. And I see something with 2 rows and 3 columns, and I'm just going to type everything in. Oops, I about made a mistake. All right, she's in. I'm going to quit. I'm a little lazy this morning. I've already done double REF at some point in time today. Probably could have got, there it is. But I wanted to show this. You can highlight old work, press enter again, and just like that, you have the answer. Now, this one is special. I keep talking about these special systems. They are patterns that we memorize. This one is special. It really, really is. That last line says no x plus no y is 1. In other words, the 0 is 1, which is false. And this is definitely an inconsistent system. Moving forward, more of the same, except here we have a 3 by 4. So second matrix, scroll to edit, and again, be playing along. What amazes me about kids is by now, you should realize that whatever you're doing in high school is either working or not working. And there's a lot of you who keep doing things that don't work, and yet you refuse to change. Like, change how you study, change how you work. Or just keep making the same bad grades. If what you're doing is working, go with it. Anyways, I got my 3 by 4. I'm going to do reduced row echelon form. And this one has answers. Hopefully interpretation is not an issue. The purpose of these videos is not to be full instruction, so hopefully you can interpret that. But remember, this is about x, y, and z. So it says x is 1, y is 3, and z is -4. If you like your triple, it'd be 1, 3, -4. So take that last column, turn it into a quarter triple. This one will bug the living snot out of kids. And I don't know why, but boy, it really does. This is Kirchhoff's rule. And kids get so confused about these i's. Well, here's what you do. You let I1 be x, I2 be y, and I3 be z. So this line right here would say y plus z is x. This right here would be 28 plus 56, which I'm really confused as to why they left the numbers there. Well, it's because they're showing on Kirchhoff's rule. Kirchhoff's rule talks about the sum of voltages and impedance and resistance and stuff. It's electrical engineering. But anyways, 28 and 56, if you put them together, we're at 76, 84, I think. But it's 84 minus 14x minus 14y. And it's equal to nothing. Let's see, in this one we have 56 minus 14x minus 7z equal to nothing. So make it x, y's, and z's first. And then think about standard form, because we have to put these, we want augmented matrices for these. So here the x is going to have to come over. This is negative x plus y plus z is 0. Second equation, we have a negative 14x, we have a negative 14y. There are no z's, and the 84 is getting shifted to the other side. Last one, we have a negative 14x. There are no y's. There's minus 7z's, and we're going to shift that 56 over and make it negative. See, now I can write the augmented matrix. And that's what this is all about. That's all it's about. It's not a hard problem. It's just the kids get really thrown off that the variables are something besides x, y, and z, or they see a diagram. I don't know. But I think that was a 3x4 matrix. Seems like I wrote 3 equations, and I'm just going to push buttons. Things in life tend to only be as hard as we want them to be. Most problems can be overcome. Not all, but most. And there we go. I should see some nice looking decimals. Let's find out. If you forgot, second matrix math, double REF, enter. Second matrix A, enter. Yeah, those are the decimals I was looking for. So that says that current 1 is 3.5, current 2 is 2.5, current 3 is 1. And that's how it is. It'll be called I1. Remember, this was I1. So impedance 1, actually this is current, isn't it? Yeah, I think I is for current. It was 3.5. Current 2 was 2.5. And current 3 is 1. And that's Kirchhoff's rule. Maybe we can go into electrical engineering one day. I don't know. The ceramics workshop makes wreaths, trees, and sleighs for sale at Christmas. So we're going to have 3 equations. We're going to have one about wreaths, one about sleighs. Oops, I forgot trees. Let's just start over. Wreaths, trees, and sleighs. A wreath takes 3 hours to prepare, 2 to paint, and 9 to fire. And let's just call these X, Y, and Z. So a wreath takes 3x, man, I'm tired, 3x, 2y, and 9z. A tree takes 15 to prepare, 3 to paint, and 4 to fire. A sleigh takes 4 to prepare, 14 to paint, and 7 to fire. If the workshop has 99 hours for prep time, 72 hours for painting, and 118 hours for firing, how many of each can be made? Let me make sure I set up the right system of equations here, because I don't think I did. Nope, I did not. Forgive me. That's wrong. The way this is worded, we have to talk about these as X, Y, and Z. All right, so we need an equation for prep time, painting, and firing. That's what we need. We need prep, painting, and firing. All right, so we talk about prep. The wreath is 3x. The tree is 15y. And the sleigh is 4. And we had 99 hours of prep time. Then we move on to painting. A wreath is 2. A sleigh is 14. Oh, I missed the tree, didn't I? Forgive me. I skipped. 3 to paint. And a sleigh is 14. And how much paint time do we have? 72 hours of paint time. And then we're on firing. A wreath takes 9 hours to fire. A tree takes 4 hours to fire. And a sleigh takes 7. And we have 118 hours of fire time. And the goal here is to figure out how many each can be made. So, one more time, back to a TI-84, back to matrices. This is a 3x4. Sometimes equations are written the way you want them to be written, and sometimes they're a little bit different. So I could see the wording of this one causing an issue. I start off by default, like there's a default way we write equations. There is, based on previous text and passages that have been done, and it turns out it wasn't that. It had to be something else. Anywho, I've got everything in. I've been doing double REF for a while now, so I'm just going to highlight and press enter. And here's my answers. How many of each thing can I make? So we called, the first thing we saw was, this is, by the way, this goes wreaths, trees, and sleds. So we can make 9 wreaths. We can make 4 trees. And we can make 3 sleighs. Easy peasy. And here's a bonus question. I'm trying to remember. No, I've already done this one because I did the bonus video, so I don't need to do this one again. Anyways, there you go. That is your twin. Now I can start working on the extra credit one.